Hi, today we're going to define a system for a simulation, and we're going to run a simulation. So let's click on system definition and we go to home. We can actually see the top menu, and we have processes, elements, routes, jobs, costs and delays. Let's click on processes and we can actually enter different processes for our system. We will enter a process called grinder 2. You can then enter a new element. An element is like a product or a service which moves through a list of processes, and so we will enter a new element called product 7AB2. Now we want to define that route for the element we've just entered, and we have all these different processes, and so we can actually click on routes, and we go to the specific product or element, product 7AB2, and we can add a process, grinder 2. And what we're basically saying is that the element goes through this process, and when it goes through the process it has a cycle time, and we will now define the cycle time based on either the time study, PTS, correlation, deviation, dispersed or centered. There's actually the information that we can read about the different cycle times: time studies, predetermined, correlation, or deviation, whereby the cycle time deviates from a mean, dispersed, whereby you have a minimum and a maximum value, and centered, where you have a minimum, a maximum, and a modal value for the cycle time. We will actually select a time study for this one. Let's choose gerunded. We can then indicate the expected hourly output when the element passes through the process. This indicate 50, and the cycle size, we'll enter 2 here, which is how many elements get out every cycle, output every cycle. We have a reject rate, our rework rate, those are percentage values, and now we can actually add a second process to the root of product 7AB2. So we double click and we want to now add a dispersed cycle time with the minimum of 1.2 and a maximum of 1.9 minutes. We can then add a third process if we want, and this one we've selected shifter. We can double click and now we will add another cycle time, and we choose a deviation with a mean of 1.4 minutes and a standard deviation of 0.21. Now we can actually click on reject rate. We can set the rework rate, and now we can indicate the costs and the delays for the jobs and the processes. So we click on job costs and we select the particular product, and then we select the processes which the product goes through, and we can add a specific cost to it. And so we call this oil. It's got a monetary value of, let's say, 23 rands, and we'll change it to 23 rands per hour. We can then add a new cost, which we can add up to 25 costs. So let's add plastic. Enter the value of 45.32, and this one we have 45.32 rands per unit. And then we can actually copy costs from one job to another. So we click on plastics and click apply, and apply to the other ones. And when we click on shifter, then there it appears. The same applies to delays. We can copy and job cost and delays from different processes to each other. So let's click on Trident. There you have 3 delays that are indicated, which we indicated before. And so we go to grinder 2, which is our new process, and as you can see, there's no delays. So let's enter a new delay, and we will call it let's call it rubber. We can also apply to other costs if it does not exist in those other if it doesn't exist in those other processes, we can apply to other processes. So let's enter 3 hours for mean time before failure and 0.2 hours for duration, or mean duration of the delay. Yeah, and let's reapply to the other ones. And now when we click on Trident, there rubber appears. So now we've added costs and we've added delays to the root. We're just applying some more. They have applied water to grinder 2, and now we can run a simulation. So now we can click on start new root simulation. We can enter the name, Pi simulation, and we want to enter the duration. Let's say 20 hours. There's actually a 50-hour limit on all our simulations. We have a mean cycle time of 1 minute for our source, standard deviation of 0.12, and a quantity per cycle of 2. Our source is the parts that actually come into the system. So we can actually begin our simulation. We can click on product 7AB2 and we can click on run. And that is how we define a system and run a simulation. Thank you.